Okay, now one thing I'd like you to do now is I want you to read through examples 1 on page 4 and example 3 on page 9 of the textbook, and pay very, very close attention to everything that's written there. On the right hand side of the solutions to these examples, there are explanations of the most significant steps of the solution. Explanations of maybe where you might get a little confused. They kind of explain different processes and techniques. So make sure you look through that whole example. These textbooks, this textbook and these examples are very well written, and they will give some great insight to help you with your homework every day. So if you cannot find something in examples that I do in class that will help you on your homework, look in the examples in the textbook, and those will help you for your homework in class. Okay, so make sure you read those, and always read those examples in class in your textbook. Okay, and the work for today, or for tomorrow basically, is going to be your class time fun. Pages 11 to 13, and as you can see there, 1 to 4, 6, 7, 9, 11, 12, and 14. Make sure you do the first few, the easier of the questions at home right now, and then the last few questions, say 6 to 14, you can do in class tomorrow, and I'll be here to help you out. Okay, we'll continue on with 1.2. This will be sort of like a double lesson because 1.2 is very short, yet fairly important. Hi, this is going to be a continuation of lesson 1.1/1.2 because 1.2 is very short. We'll tag this along onto the 1.1 day. Now this isn't necessarily in the ministry curriculum, but I think it's important to kind of get an idea of what we do with absolute values, just so you have a working knowledge of this. Okay, so basically f of x equals the square root of x, or sorry, the absolute value of x is the absolute value function, which makes sense. On a number line, basically it's saying that the absolute value is determining the distance from 0. So the absolute value of -5 is 5 units from the origin. The absolute value of 5 is also 5 units from the origin. Okay, so that's basically what it's doing, is saying just the distance from the origin. So then if we evaluate these, we're just saying, well, how far are these values from the origin? Well, the absolute value of 3 is 3 units from the origin. Absolute value of -7 is 7 units from the origin. We treat absolute values as brackets, so we do whatever's inside first, just like we would with order of operations. So the absolute value of 5 minus 3 is the absolute value of 2, which is 2 units from the origin. And for part D, the absolute value of -9 plus 4, that's the absolute value of -5, which is 5 units from the origin. When we come to express the function notation in absolute value notation, you have to again think, well, where do these lie on a number line like we see up here? Okay, so I'll just pan that up a little bit. So when we're looking at x is less than -5 or x is greater than 5, what are actually these values? So if we take the positive ones, which are a little bit easier to see, x is greater than 5, that means that x would be 6 or 7 or 8 or 9, etc. It's on to infinity. Or when x is -5, or actually, and they could even be decimal values, it could be like 5.1 or 5.01 or 5.001, etc. It can be as close to 5 as possible, but just has to be greater than 5. And so for x is less than -5, What's less than negative 5? It would be negative 6 or negative 7 or negative 8, or even any decimal value, negative 5.1, negative 5.01, or negative 5 1/4, or whatever it could be. So the actual values are getting larger even though they're negative, which means they're actually, the actual value of it is negative, or sorry, getting smaller. That's why we're saying less than here. So in order to write that, because the actual values are getting further away from the origin, we would say the absolute value of x is greater than 5. When we have negative 3 is less than or equal to x less than or equal to positive 3, we see that the values here are basically, the values of x are between negative 3 and 3. So if we take a look up here, if the values up here were between negative 5 and 5, there would be all these values inside here. So then we could say here that the absolute value of x is less than or equal to 3, because all the values are less than 3 units away from the origin on either side of 0. Now we move along to doing a little bit of graphing on a number line. We see here that x is less than or equal to positive 4, so x is less than or equal to 4 units from the origin. So we can just say that there's the origin of 0, here's 4, here's negative 4, and if all the values are less than or equal to 4 values away from, or 4 units away from the origin, if it's less than, we know it's going to be in here. So I'm going to say that, I'm going to draw it with a double line just to kind of, I should be doing this with a ruler. So it's between negative 4 and 4. Now when it's equal to, that means that it does contain negative 4 and it does contain positive 4. So that's when we would put a closed circle on both negative 4 and 4. Then when we go to B, absolute value of x is greater than 7. Again, we started off with the origin. We mark 7 and negative 7. And if it's greater than 7, well, it's easy on the positive side. We know it's going to be greater than 7, so anything larger than 7, 7.25, 7 1/3, 8, 9, 100, whatever it may be. So we know what's going on in this direction. And so that means if it's being 7 units, it's greater than 7 units away from the origin, then it's going to be going in the opposite direction, also in the negative direction. And now because it doesn't say equal to, that means that it's going to be, the 7 and negative 7 are not in the domain of the function, which means that we'll put what kind of circle there, closed or open? Right, we're going to put an open circle there and an open circle there. Because we can't really draw that accurately, we wouldn't be able to just stop the line very, very close to the negative 7 or the 7 mark on the number line, because we could always magnify it and get even closer. So in order to draw it within our means, is we'll use an open circle to indicate that we can get as close as we can mathematically, but we just can't draw it that accurately. So we use an open circle to say that 7 and negative 7 are not included in the domain of that function. Okay, and then now we're going to move on to the last example. We want to rewrite what's on the number line here, using absolute value notation. Well, we've seen an example up at the top here showing that here when the absolute value of x is less than 5, it's between negative 5 and 5. Here we see when it's less than or equal to 4, it's between negative 4 and 4. When it's greater than 7, we see that it's going to be from 7 and above, or negative 7 and below. Well, here we see the same situation as in this example, where it's starting at 3 and going above, and starting at negative 3 and going below, more negative, and they're both open circles. So what would be the absolute value notation for this function? I always like to do the hard part for you first. And so that would be following the example up here, absolute value of x greater than 3. Okay, so there's a couple questions for you, 1 to 5, and just a note that the answer for 4D should be absolute value of x is greater than 7. Okay, thank you for your attention, and we'll see you in class.